All right, so if you see something like this, we know that it's going to move which way because of the stuff in the parentheses? We're going
right.
To the right 3, and we're also going up 2. So we're taking our x squared graph and we're going to shift it that much. So we need to know where our points go after we get our vertex. I'll just do a couple more. So I go right 3 and up 2. That's going to be my vertex. Is this parabola right side up or is it upside down? It's right side up because there's a positive in the front of our parentheses. If there was a negative in the front there, it would be upside down. Okay? And now we've got to get the rest of our points for our parabola. So if you're thinking about a parabola is just x squared, right? So however much we're going in the x direction, we'll square that number, and that tells us how much we're going up because it's an x squared graph. So if I'm going 1 over, what is 1 squared? 1. So I'm going 1 over and 1 up. And a parabola is symmetrical, so you do it on both sides. So from your vertex, over 1, up 1. Okay? And now if I'm going back to the vertex, I'm going to go over 2. What is 2 squared? 4. So we go over 2 and up 1, 2, 3, 4. And do it on both sides. And you will get your basic parabola. So if you wanted to write that to the side, we're going over 1 and then up 1. This is from the vertex for both of them. And then over 2, up 4. And the reason that it's 4 is because we're squaring our x value. Once you move left and right, you square that, and that's how high up you're going from your vertex. So if you're given a graph like this, see where it moves, if it's upside down or right side up, and then you can apply this pattern. We'll do a vertical stretch one just so you can see how the ups and downs are affected by that. So a problem like this, 2 times x plus 1 squared minus 3. Someone tell me what's one way that this moves.
Down 3.
Good, thank you. Down 3. What's another way that it moves? Left 1. Okay. And then the 2 in the front tells us we have a vertical stretch of 2. And the way that you need to think about that when you're graphing is a vertical stretch of 2 is essentially just a multiplier of your up values. So whatever you would normally go up from x squared, you're going to multiply that by 2. Okay? So this is going to be a multiplier of the y values or your up values, whatever you want to call these two numbers. All right, so right now I want everybody to go ahead and put your vertex in the right position on your graph. Okay, so is our vertex 1 to the left and 3 down? That's where our vertex goes. And then we are going to think, is it up or down? Well, it's up because it's positive. And normally we go over 1, up 1. But 2 is going to be our multiplier. So whatever we go up, we're going to multiply that by 2. So we're still go over 1, but instead of going up 1, we're going to go up how many? 2, because 1 times 2 is 2. And we do that on both sides. It's symmetrical. Then go back to the vertex. We're going to go over 2. Normally we go up 4, but we had a multiplier of 2. So instead of going up 4, we're going to go up how many? 8, because we multiplied it by 2. So over 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8. Look, it's perfectly the amount of tick marks I made. Maybe that was intentional. Okay. Any questions on how we stretched it? Okay.
How did you get 8?
Normally we go up 4, right?
Mm-hmm.
So we multiplied that by 2 because we had a multiplier of 2 here. This number in the front tells us we multiply our ups by that. All right, I'm going to go back to this graph that we have here, and we're going to write down everything else that we know about it so that we can see, I don't know what we're trying to see, what I was trying to say. Oh, we're going to write down if it's a max or a min, what the vertex is, and what the domain and range are from a graph so we can see where how all these numbers are related, okay? So what is the ordered pair from the vertex from the first graph that we made? So our vertex is 3, 2, right?
3, 2.
Uh-huh. Is our vertex a maximum or minimum value?
Max.
Is it the highest point on the graph or the lowest point on the graph?
The lowest.
The lowest, so it is a
Minimum.
minimum. Yeah, good. So we have a minimum. Our minimum value, when we do minimums, these are the y values. What is the lowest value on the graph? What's the lowest y value we get to? 2. So our minimum is 2. What would our domain be? Do we have any denominators, any square roots, anything that messes with our domain? Nope. So our domain, since we don't have anything, you can either write all reals or we can say negative infinity to infinity. So remember with quadratics, it's always all reals. You'll go to the left or to the right forever and ever, nothing, there's no stopping there. But our range is something different. It's not all reals. Where do our y values start? 2, and they're going up, right? Do we include 2? Yep, so our range, we can say y is greater than or equal to 2. You could do interval notation as well. 2 to infinity. Oh, when I was making these problems in CUDA last night, I think I might have just used X's for everything because it was 10 something at night. So if you're looking at those and it says X for the range, just know that I made a mistake. I just thought about that right now. I was just typing all kinds of X's, filling in all those multiple choice options. Okay. So if you see a graph, you can tell me the vertex. You can say if it's maximum or minimum, what the domain is, and what the range is. So go ahead and try that on this second one. Fill out all those same things on this second parabola, and then we'll go through how to do it if it's in standard form.
I have a
Yes,
question.
ma'am.
So if the question asks what's the minimum and the maximum, what would be the maximum answer?
There's not a maximum because the two arrows just keep going forever. That one has either a minimum or a maximum.
Okay.
Because it doesn't, there's no highest value because it goes all the way up. All right, so I think y'all are probably getting close. I'll write down what we're finding so we can. Who wants to tell me the vertex?
-1, -3.
Good, thank you. And then I said it's a minimum. It's on the bottom. If it were upside down, we'd have a maximum. So this is a minimum. And our minimum value is, Alan?
-3.
-3, good. Our domain, all reals, all the time for our quadratics. And then our range. Who wants to tell me the range? Grace?
Y is greater than equal
to negative. Yeah.
-2.
Okay, that's the lowest value. So everything is higher than that. So do we notice that from our vertex, you could look at your vertex and you know the minimum or maximum, it's the Y value in your vertex. It also is the value for your range. Okay. Your X value will show up from your vertex. If they ask you, sometimes they do, they say, what's the minimum? And then they ask, and at what X value does that minimum occur? So if they say, and at what X value is the minimum, you would say the minimum is at X equals, the minimum occurs when X equals -1. But when they just say minimum, you're putting the Y value down, unless they actually ask for it. All right. So we're going to go now from standard form into the vertex form. We'll be able to transfer them back and forth. Because if you're noticing from the H and the K are just what gives us our vertex, right? That tells us where we start. That's our vertex for that. So if we could find the vertex, if we're in standard form, we'll be able to switch it into the vertex form really easily. Okay.
The two graphs that we did, those were standard?
These are written in vertex form because you can look at them and see what the vertex is. Yeah. So the first thing we have to do before we can switch them from one form to the other, we have to know how to find our vertex if we're in standard form. And we have a clever little formula to help us find our vertex if we're in standard form. And you'll probably remember this from last year. So this is if we are in the ax squared plus bx plus c form. If they give you this and they say, what is the vertex? Or what is the max or min? Or what is the domain? Because you've got to have those vertex numbers to be able to answer all those questions. You use a simple little formula. And does anybody know it? Anybody remember it? Maybe not. Okay. So it's x equals -b over 2a. Does that ring any bells? All right. So to get the x for our vertex, we're going to do -b. So the b is what's ever in front of the x over 2 times a, and the a is in front of the x squared. So that gives us our x value. Okay. And then to find the y of the vertex, you have to plug in the x in your equation. So we'll start out with not too hard one. And we want to find the vertex. Then once we know what the vertex is, we can put it into vertex form. So we're going to write x equals negative b over 2a. What is the b value that we have?
-8.
So we have negative -8, which makes a
Positive.
+8 over, what's our a value? 1. So one thing that messes people up is they try to put this in the calculator, like 8 divided by 2 times 1, and they don't do parentheses right. Y'all know how to multiply 2 times almost any number that's going to be in the front right here. So do the 2 times the 8 in your head. 2 times 1 is just 2. Okay, it's going to save you some trouble if you're calculating later. So 8 divided by 2 is simply 4. Thank you. So that gives you the x value. Now to find your y value, you're going to plug 4 in for your x's. So just plugged into that equation. So 16 minus 32 plus 8 gives us, anybody got it? -8, right? That's what you're going to say? Okay. All right, so -8. So our vertex is the ordered pair for -8. Can I tell if it's a max or a min?
No. Or
What kind of parabola?
yes.
This is going to be right set up. It's going to be right set up, right? Because it's
-8.
positive. Yep. So we know it looks like this. So we're going to have a minimum, and our minimum is -8. Okay. We know our domain. Our domain is always all reals for these problems. So if you're solving, I'm just writing all the stuff down. They're not going to ask you this on all the problems, but I'm just showing you how we can figure it out. Okay. In our range, what's our lowest y value? -8. So all the other y's are going to be above that, right? So y is greater than or equal to -8. Okay. All right. So that's just what we did once we looked at a graph, but now we know once we find the vertex, we can answer all of those questions for it. But here's the fun part, and it's kind of like working backwards. The vertex form, and I'll scroll back down if you're still writing this. Vertex form, all we have to fill in is the vertical stretch or compress, and then how it shifts, right? Our shifty part in our graph. So we can use the vertex that we know, work backwards to get vertex form. So if I'm writing this now in vertex form, I want to think about how this graph is moving. If my vertex is 4, -8, it moved to the right 4, right? It went right 4 and it went down 8. If you're at the point, right. So it's right 4 and down 8. So I'm going to write vertex form so that that's the shift that's going to happen. I'm just going to say what the formula was first so that you have that if you're. So that's what we want to fill out, but we wanted to end up with a vertex of 4, -8. So shifted right 4 and down 8. Was there a vertical stretch or compress in this problem? The A value here matches the A value here. So that was a 1. There's not a vertical stretch or compress in this problem. So the A value is just 1, so we're not going to really see anything with it. Okay. If I want my graph to go to the right 4, what needs to be in parentheses? X minus 4. Yep, I'm seeing those hand motions. And if I want it to go down 8, what needs to be after the fact? Minus 8. Good. So do you see how we took it? Once you know the vertex and know how it needs to shift, you can easily rewrite it in vertex form. We'll do one more. Try this one on your own. See how it goes. Let's go for it. Sounds perfect. Here you go. All I want you to do is to find the vertex and put it in vertex form. You don't have to do all the other stuff on the side. So we're going to say f of x equals 3x squared minus 12x plus 13. So find your vertex and then write it in vertex form and see if you got this. Okay, we about ready to check it? All right. So we're going to do negative b over 2a. Negative negative 12 makes a positive 12. 2 times 3 is 6. 12 divided by 6 is 2. Then to find our y, we're going to plug in 2. And I think this equals 1, right? Okay, so that's 1. So we know our vertex is 2, 1, which means that we would be, when we're moving, that this is going right 2 and going up 1. So that's going to help us out. And we also have an a value. Our a value is 3. So we have to put that into our vertex form. So remember, this was vertex form. So our a value goes in as 3, because that was our vertical stretch. We're going to the right 2, so x minus 2, and we're going up 1. Okay. All right, and from this, let's see what else we know. We know that's our vertex. Is this a maximum or minimum? It's going to be a minimum. Always think about, is the parabola up or down? So you might just want to kind of sketch that at the end. This is an up parabola, so it's got a minimum. What is the minimum? 1, right? Our domain is always all reals. Our range, if our minimum's at 1, our range is all the stuff that's more than 1. You will have some problems today that are upside down. I guess I just didn't have any examples that had maximums. But if it's a maximum, it's y is less than instead of greater than. So this is y is greater than or equal to 1. One other thing I said at the very beginning, I'll see if you remember. If you're looking at it in standard form, which of these numbers is the y-intercept?
13.
13. So if you have it in standard form, you can easily write also the y-intercept is 13. So if you're sketching the graph, you know it needs to cross at 13 on the y-axis. So that's all the stuff that we can figure out from our equation, which would help us graph it. But I don't really want to because it's a stretch of 3. But we would go right 2 over 1, over 1 up 1, over 1 up 3, sorry, and then over 2 up 12. I just don't want to do 12 points. Why is it going to be 12 for the second up? 4 times 3. Yep, JC, good job. All right. So anytime they ask you for it's about to be. Anytime they ask you for a maximum, it is all you're looking for is the y of the vertex. Anytime they ask you about the range, you have to find the y of the vertex. Anytime they ask for the vertex, you got to find the vertex. So you guys are going to be negative b over 2a in it like a whole bunch today on your assignment. So if you have it in standard form and you're like, I don't know how to find the domain in standard form, find the vertex. So always, when in doubt, just say, let me find that vertex. And you'll be able to do it. There are some word problems, but word problems in sections like this, just identify the equation, find the vertex. And that will tell you all that you need to know about max, mins, and everything else. All right. It is homework time. There's only like 20 problems, so it shouldn't be that bad. But you are going to have to write down ones that you're working out like this. If it's just a transforming graph, look at problem, you don't have to write it down. But anything where you got to switch back and forth, make sure that you do those on your paper.